This is a walkthrough of problem 4 on exam 1 from module 3, which can be found on page 69 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 4 is a 12-volt battery is hooked up across two parallel thin conducting plates that are squares with 15 centimeter sides. Shown right here, the plates are 3 centimeters apart. There's a vacuum between them. You shoot a proton directly through the plates at a speed of 300,000 meters per second. What is the vertical deflection of the proton when it exits the plate? So the proton is going to be pushed up or down by the field, and it's going to curve a little bit, and we want to know the vertical deflection. Let's draw a little bit better diagram, nice and big, so we can see what's going on. Here are the plates, 3 centimeters apart. You shoot the proton in, and it gets pushed, and there's some vertical deflection. We want to know what that distance is. How are we going to do this? Well, the proton's pushed downward by the field in this diagram. If we have the field and the charge on the proton, we can get the force. If we get the force, we can get the acceleration. If we get the acceleration, we can get the distance. And let's just start. The voltage difference drops 12 volts over 3 centimeters. That's what it says. 12-volt battery, 3 centimeters apart. It drops 12 volts in 3 centimeters. So the field is 4 volts every centimeter, which is 400 volts every meter, which is 400 newtons per coulomb. So we have the field, we can get the vertical force. F is QE. We have the charge on the proton. The force, 6.4 times 10 to the minus 17th newtons. So we can get the vertical acceleration. F equals ma. We know the force, we know the mass. We can calculate the acceleration. 3.83 times 10 to the 10th meters per second squared. That's vertically. The horizontal acceleration is 0. There's no force in the horizontal direction. This is similar to projectile motion, but instead of gravity pulling it up and down, it's the electric field. We can use the horizontal direction to get the time. We know the speed in the horizontal direction. It's 300,000 meters per second, and it doesn't change. There's no acceleration in that direction, and we know it has to go 15 centimeters in the x direction to get through the plates. So we change the 15 centimeters to meters, and we get 5 times 10 to the minus 7 seconds. The proton does not spend a lot of time between the plates because it's going so fast. We can use that time in the vertical direction. So VIY is 0. It's going only horizontally. We can calculate the vertical deflection. We have the acceleration, we have the time. 0.00479 meters, which is 4.8 millimeters. And we can put that on the diagram to demonstrate that we know what the heck we're talking about. That's the vertical deflection of the proton. The whole distance is 3 centimeters. That's about a half a centimeter. That's problem 4.